My talk would be a bit different from the talk that was given before, because what we're trying to do with the technology we developed for Bitcoin is the first thing we try to question everything. And the most important question is always why we need some technology, why we are building some technology. Because of course you can create a lot of interesting, important things like beautiful ID application, digital IDs, digital concentration camps, and many other digital things which would be really efficient in what they do. Unfortunately, the goals and the result of such technologies would be quite different from what people expect. So I will start with some basics and then try to explain how we see the technology can be properly used to increase the freedom of people instead of just making a more digital controlled environments and digital surveillance. So the question is why we need things like digital identity. What is the goal we have? Well, if the goal is that we would like to have everybody accounted for, build systems like in China, of course, you need something blockchain-based. You need something which really takes each person into some registry, fully accessible by the authorized parties. Maybe it would be a broad publicity. Maybe anybody can check that registry. So we are talking about a public blockchain. Or maybe it would be something less accessible. But the question is, if we need to have a control over the data, we need to own data. And we know that the data ownership is one of the most critical things in this world today, in the new digital world today. Because probably any of you, of course, not just heard by witness, by yourself, the tragedy which we had around Kiev, like with Bucha and the Russian forces came. Before invasion, they were able to hack the registries of the gun owners and many other registries. They basically hacked all the governmental registries which we have in Ukraine, and they used that to target personally people who were pro-Ukrainian or who were owning some weapon on any other threats that they consider as threats, and they came after them and literally killed them. So that's the risk of keeping any data in the registry. That's the risk of centralization. And digital identity can easily add to that risks. So the goal that we are trying to achieve is build a system that can protect us from such risks, which we don't want to have. And the technology that we believe actually able to do that is called client-side validation. And it's the idea actually which were created many years ago, in 2040 probably, by Peter Todd, who is there in the audience. And it was a further development of the idea which was behind the blockchain. The difference is that with the blockchain, we have a situation where everybody validates everything. And this creates two main problems any blockchain system faces. The first problem is that it's not scalable. You can imagine that if everybody has to validate everybody else's data, transactions, actions, it really doesn't scale. When you go from 1 to 10 participants, it will work. When you go from 10 participants to 10 billion participants, it just doesn't work. The second problem is that it doesn't have a privacy property, because if everybody validates everything for everybody else, well, everything is public. Everything that has to be validated has to be public. And the solution is very simple. The solution is that we don't need, in the most of the cases, like in 99% of the cases that we have in decentralized systems, to have everybody validate everything else. We just need somebody who are interested in certain form of data to check his own data on the client side, meaning I'm a client accepting certain form of data. Maybe it's a transfer of some value of tokens or some digital identity. There is no point for me to validate some other's identity who I'm not interested in. I'm just checking what I want to check, and I don't force everybody else to check everything in the world. And I'm also not using my computational power broad bandwidth capacity or storage to check everything what happens in the world. So that's pretty simple idea of client-side validation. And the main problem with that is how we make sure that there are some singular events which can't be happening twice, just once. For instance, the most common case is the money. So if you pay me some money, let's say $10, I need to make sure that you haven't paid the same $10 to somebody else. Otherwise, you have a double spend. And that's why actually Bitcoin and digital currencies, they had this blockchain thing embedded. So the idea of Satoshi was actually to combine the blockchain, which he hadn't invented. He just took the different aspects of technology and put them together with the idea of digital money, such that you use blockchain where everybody validates each transaction and combine that with the money. And in that way, you are sure that the $10 or 10 Bitcoins or 0.10 Bitcoins, which you have received, were not spent before, because you validated each one single spend which happened in the world up to this point, and you check that. So you got this non-scalable, non-private system, which is called blockchain, and which backs Bitcoin as money. Can we do something better than that? Well, when we come to identity, actually the answer is for sure we can do that. And now let's move to the problems which we have with identities and why we actually need blockchain. And the question is not even why we need it. The question is, do we need it at all? I'd like to ask the audience, did any of you ever use PGP or GPG, GNU-PG, Web of Trust in any aspect? Please raise your hand if you tried. Yeah, there are a few people who know. So actually, the digital identity system is already out there for more than a decade. Probably it's more than 2 decades already. And you don't need anything else for creating digital identity is then create a pair of keys, private and public key, and publish your public key to those who will be interacting with you. You don't need any blockchain of any sort. And that's it. And it was kind of working. And the question is why it's not adopted broadly today. Well, the problem, there are 2 main reasons why it wasn't adopted. The first reason is that people don't need a sovereign identity. They need a government, they need a centralized power that decide for them. They don't need freedom. And like 90% of the world population just don't care and they don't need it. It wasn't a product which was solving anybody's need. And those who actually had that need, they were using it quite a lot. The second problem, though, is not just the absence of the need, but the fact that other than creating an identity, there is a different procedure which you have to support if you're building a digital identity, which is a revocation, a key revocation. Why the key revocation is important? It is important because if your private key is lost or got compromised, you need to inform other people about the fact that it was compromised, that it's not valid anymore. Because if somebody stolen your key, they would be able to create a signature with your key, meaning that it can be legally a binding thing, and you can't be claimed for doing something that you haven't done. So the loss of the privacy and the loss of private key is very important here. So you need somehow to inform all of the world that you have lost your private key. And that's where the PGP or GPG had this issue, the second issue, that there was no way how you can do it. Well, there was a thing called key servers, which was developed, and you can actually send the revocation certificate to those servers. But there is no attested event when specifically you did the key revocation, and it's not something that was globally informed. So that's actually was a reason why a lot of people started looking into blockchain. Well, many people started looking into blockchain because it was a hype or a way how to raise money for their startup. But actually, there was some rationale about this key revocation. And the naive idea, which most of the startups got, is let's publish the identity into the blockchain and as well publish the revocation of the identity into the blockchain. And the instant problem you get with such approach is that basically it doesn't scale. If you try to build an identity system that can work with billions of people, like at least each people should be each person on the world in the world should be able to generate a new identity. Well, if we are talking about 10 of billion people. And also, if you get into this account the devices, which also need to have a distinct identities, Internet of Things, you are talking about hundreds of billion of identities. And you simply can't have a blockchain that is able to store that amount of data and to store that amount of transactions, not to talk about the revocation, because they will be adding to that billions of transactions. So we see that this naive approach doesn't work at all. And we need something different. So that's question. That's where we have started. And we started with a questioning what we actually need. Is there any need of publishing the creation of the identity to the Bitcoin blockchain or to any other blockchain? And actually, the answer is no, because we had these PGP-like systems working for more than two decades. So maybe we don't need to publish a digital identity into the blockchain. We don't need this narrow window of low throughput blockchain transactions to be involved in a protocol which is related to digital identity. And that's where the many existing proposals on digital identity are actually don't work, because they exist as a proposals, but they can't be put into a real world, because the moment people start using them, they are not able to go through all these transactions. You can imagine, if people don't need a PGP, which is free of charge, why would they ever do a digital identity where they need to buy some digital currency first, and they pay with this digital currency for the creation of identity? Well, it's no way. And that people just don't use those identities. Maybe there are already thousands of proposals for digital identity based on blockchain. And the most famous one, for instance, is one Ion from Microsoft. Or recently it was Michael Saylor doing the digital identity proposal based on blockchain. They all suffered the same problem. So it's just a dead end, and they were born dead from the beginning. And the initiative I am presenting today is the self-sovereign identity, which doesn't need to be restricted for creating a Bitcoin or any other transaction in order to create your identity. It works pretty much the same way as PGP or OpenGPG. It is just a key, a private key which you keep for yourself, and a public key which you share with the people with whom you would like interact. It's just that the format, how this public key is stored, is more modern and more easy to share in the form of URL. I will switch the presentation in a few minutes, and I will show how it looks like. The main thing which is important is that the only time when you touch blockchain is when you need to revoke a key. And here, another problem which happens, how you can signal through blockchain the key revocation globally. You need to, in case of Bitcoin, which is, as of today, still the most censorship-resistant medium, and when you talk about digital identity, self-sovereign identity, you probably need some really censorship-resistant medium. In order to add any information into Bitcoin blockchain, you actually need to spend some output. And to spend some output, you need to own some output. And it brings us back to the round one, where we actually were. Like, if you create a digital identity which may be revoked, you basically need to create an output eventually spent to revoke this identity. And again, this wouldn't scale. So we came with a different solution, and probably at this point I will switch to the slides because it would be hard to explain the rest without them. I already gone through all these ideas, so probably I wouldn't be just repeating. So this was the naive design where we have an identity defined as a key and some transaction ID with a number, with the output number, basically unspent transaction output, such that when you'd like to revoke the key, you spend this output and you signal the revocation. This mechanism actually was pretty well described and designed again by Peter Todd. It was called single-use seals. And their meaning is that when you attach to some unspent transaction output some meaning and you communicate that meaning to another person, the moment when you spend that transaction output, you basically signal to that person some form of information. And you can do that only once, because in Bitcoin, you can spend the output only once. And that's why it's single-use seal. You can use it as a way of sealing over some message which will be understood just by those with whom you shared your information. And the rest of the world wouldn't see anything specific about that transaction output. So it was a great design, and we are using that a lot in a different technology we are developing, which is RGB, the smart contracts on Bitcoin. But because we today talk about a different topic, we found that actually we can't use it, because if we use it this way, again, we have this problem of scalability. When you create a digital identity, you need to create a transaction output, which you need to be able to spend. So now you need to keep two keys, one for spending Bitcoin transaction output and another one for your identity. And it makes things even more complicated and less scalable than with the PGP. More complicated with a PGP and the same unscalable as with Bitcoin transaction. So we had come with a different idea that we actually can use this piece of data which appeared in the Taproot soft fork, and this piece of data called annex. So what is annex? I will briefly explain. Bitcoin had several soft forks over its history. There was a SegWit soft fork, which make it more robust, and it created a lot of things. Specifically, what it did is that it separated the data required for the verification of signatures from the transaction itself. And by doing that, it fixed a vulnerability, which was signature malleability and SIP script malleability. But also it created this block of data, witness data, which are not part of the transaction ID and which can contain information used by Bitcoin script for the validation of transactions. Specifically, in most of the cases, it's just a signature. And then Taproot fork happened. It also added to this design. And one of the things that Taproot soft fork has added is the annex field of the witness, transaction witness, or transaction input witness. What this annex thing is about? Well, it is reserved for some future use. The only important thing about annex is that today it is ignored. The data you store in the annex are ignored. And the second, the data you put into the annex are signed, so you can't modify them. And you can actually, because of these two properties, you can put arbitrary data into the annex of arbitrary transaction. And when you add those data, you can be sure that they got into the blockchain. You don't need to specifically design a previous output like you do with the ordinals and other witness-based data storage mechanisms, where you actually need two transactions. The first one creates the output, the other spends with this witness data. If you use annex, you don't need to do that. And this annex can be malleated, can be modified by miners or the network because you sign it. So the idea is that the moment where you revoke your key, you publish the revocation certificate of whatever form you choose into the annex of any Bitcoin transaction. So you don't need to pre-create the Bitcoin transaction output. It's just that Bitcoin transactions happen all the time. They are normal monetary transactions. And some of those who create Bitcoin transactions, they would like to be paid for including arbitrary data into the annex. And you put your revocation certificate into the annex, you pay some small fee at the moment of revocation, and you got your revocation certificate published in the blockchain. So by doing that, you get a system that scales. You only need to add some data to Bitcoin blockchain the moment you revoke the key, which happens really rarely comparing to the creation of the key. You create public keys without a single Bitcoin transaction. You don't need to buy Bitcoin. You don't need to publish a transaction. You don't need anything. The only time when you need something is to contact the Bitcoin network and find who is willing to, for a small fee to include your revocation certificate in the annex of the taproot spend. And that's it. So this is much more scalable design. And this design is quite robust because, again, with like it's not specific to identities. The annex, with the more and more adoption of annex happening, can be used for different tasks. And the external user who don't know about your identity wouldn't recognize what this information actually means. It's just a message which can be read by those people who already informed about your identity, and they can check that you actually did the revocation. And this design, so that's how we built the, you can actually do that for PGP and other systems. You don't need a new identity system to use that mechanism. It's just that we decided to build something more modern than PGP and SSH, and that's where we have this SSI. SSID was the previous name. So that's why we have the SSI system, but basically nothing prevents you from doing the same with the PGP keys and revoking PGP keys in that way. It's just that with the PGP key, the revocation certificate is quite large, and basically it would be increasing the cost of the revocation transaction, so you will pay more than with the SSI. So what this new SSI thing is? Well, this new SSI thing looks like a very short URI, which consists of the prefix, which is SSI, and two dots, followed by a base 64 encoded public key data. And that's literally how it looks in reality. These data, they are chunked, so they are much easy to read and check if you need to dictate them. And additionally, you can have some optional parts of this identity. Again, they are just parts of the URI. You can provide some key server path, and this key server can operate under different protocols. So it can be even a more old PGP related protocols like HTTP, or it can be some new protocols like Nostr, or another protocol which we do for data availability called Storm. And actually, you can also include the signature over your public key and some additional data, because you can add more parameters like your name and so on, or you can download this data from URL you provide, like meta information about your identity, and you can put the signature over those data right into the URL, or again, make it a part of the data that you return from your web server. But again, this identity can work without any web server, so you can just structure it as this URI plus a signature, and that's it. It's all you need. And you can distribute that and sign information with that, and it can look like this. You can actually, what we are doing is we develop a PGP extension that allows you to add a SSI signature to arbitrary message in such a way. So that's basically everything I was going to tell you about this new identity system. We have developed an early prototype. You can find it in the GitHub. It's lnp/bp/SSI. I will share a different window with you to demonstrate that. Give me just 1 second. Mm-hmm. You go to lnp/bp, and here you have the SSI repository. It's a Rust code, so you can download, fork it, and compile, and you can start using the SSI identity system from the as an early adopter. We right now support two curves. We support the curve 25519, and we also support the Bitcoin curve, which is SEC-P256. And you choose your curve, you generate the key. For instance, here how the key generation looks like. I will share with you my terminal screen. Here, you see the identities that I have locally. Here they are. You can actually define an expiry date, and you can check the validity. You can create signatures with this identity. You can encode files, you can decode, you can check signatures of others. So the normal functions that you can do with PGP and GPG, but structured with this way of revoking the data as I just described. I have finished, so probably if you have time for questions and answers, I will be happy to answer them.
Hey, first things first, I just
Hello.
I just want to say thank you for such a comprehensive lecture. There are a lot of interesting things for me, and I'm just kind of interested in just to be sure that I'm on the same page with you. So you're talking about writing arbitrary data in the witness field, right?
Not witness, annex field of the witness or taproot spent out input.
Okay, right. Why am I asking this question? It's just because, well, if we write some arbitrary data in the witness field, this transaction could be marked as unstandard. And that means that the node, just correct me if I'm wrong, the node may not include this transaction into the mempool, and that means that the transactions couldn't be mined in the future. So do you have the same problem with the annex field, or?
Well, as up to date, the annex field is standard. So it's not something unstandard. And here, maybe if you use it for like multi-megabyte files, it wouldn't work. But for the revocation certificate, it's just a few hundred bytes. So it's pretty tiny. And from the existing standardness rules of Bitcoin Core and all other software, it's fully standard. So today it will be propagated by the network. Of course, like nothing prevents Bitcoin Core developers or Bitcoin nodes from changing the standardness rule and filtering out the witness, the annex containing transactions. But again, like with the ordinals, I'm pretty sure that the miners will use this opportunity to extract additional value, and they will be providing the service by themselves. So you can just contact the miners or any mining acceleration services like mempool has, and publish your revocation through them. So like the spam filtering haven't stopped ordinals from working anyway. So, and Peter probably will say more on that spam filtering in Bitcoin just simply doesn't work.
All right, thank you. And there's one more question for me. So as far as I understand, there could be some. I'm just trying to mix the previous lecture and that one. And so let's say we have some kind of a identity provider that writes some identity onto the blockchain, onto the Bitcoin blockchain, and it uses the same key for signing a transaction, right? And everybody could prove that everything is fine. And let's say, could there be some kind of attacker that could attack the identity provider and just force it to not to publish such transactions and not to sign it?
Well, first, here we don't publish identity to blockchain. Second, there is no identity providers, so literally there is no point of attack here.
Okay, I got you. Thank you.
That was the whole point, how to avoid all these parts which can be avoided, like introducing your man in the middle on your service providers and so on and so forth. So make it self-sovereign, right? Meaning that you're actually the only person who controls it.
I have a question. If I understand correct, if you need to prove something, we need to use separate ID for every kind of proof I want to prove, right?
So, no. Yeah, well, you can create your identity as many as you need, but you can like be happy with a single identity and sign with that identity all the proofs you need. You don't put the signatures into blockchain. It's purely peer-to-peer, like with a PGP. It's like you can think about this PGP with a blockchain-based revocation.
So I can update my ID information. For instance, I can add name, surname, any data, use PGP for that. And in the case I need to revoke this data, I just publish transaction and that's it.
Exactly.
Так, дякую.